Limits of trig functions. All right, so in this lesson we're going to be, well, what it sounds like, we're going to be taking limits now, which you guys are used to, of trig functions. So let's jump into it. So in order to take a limit of other trig functions, we really want to get a handle on a few basic ones, or a few kind of foundations. So here they are. So we want to figure out what the limit of, as x approaches 0, of sine x, the limit as x approaches 0 of cos x, the limit as x approaches 0 of sine x over cos x. And actually, I'm going to write kind of variation on that one too. Well, you know what, I'll kind of bring that up in a little bit. So looking at these first two, this is actually going to be pretty simple, right? So when we take the limit of some function, first we always want to check, can we just throw like the number like 0 in for x? Like, what do we get there? Maybe it works, right? Remember when we had to like manipulate these limit expressions, it was because we were dividing by 0, right? That was always the problem. Or maybe that's not a problem, right? So we always want to check. So let's just try throwing 0 in there. Well, sine of 0 is, well, that's not really kind of asking what is the y value on the unit circle when we have an angle of 0 radians or 0 degrees, either one. Well, in that case, it's going to be 0. All right, so now for the next one, again, kind of thinking on that unit circle, if we had 0 cos 0 degrees, just throw 0 in for that, then we're going to have a value of 1, right? So like our x value is 1 all the way across. So now let's look at the next one though. So in this case, we've got the limit as x approaches 0 of sine x over x. So if I throw 0 into the top, that'd be 0. And then if I throw 0 in for the bottom, well, that's 0. We can't have that, right? That does not exist. Or you get an error. Right? Well, that's the way it appears anyway. But we ran into this before when we were taking limits in earlier lessons, right? Let's handle it the same way as we did before. Let's approach it from the right, and then let's approach it from the left and see what number we're actually approaching. You probably tell it's not going to be, or that it will exist here in the end by the tone of my voice. But anyway, so if we throw 0.1 in for x, top and bottom there, right? We end up getting 0.998334. And if we throw in 0.01, we get 0.999983, and then 0.001 would be 0.99, a bunch of 9s, 5, 6 9s, and then 83. All right, you're probably seeing where we're going with this. All right, so if we throw in negative 0.1, so approaching it from the left now, we get 0.998334, and really the same numbers as we did before, don't we? All right, so what is that approaching? I think you guys can probably see it from there. It's getting ever closer to 1. So it turns out, yeah, the limit of as x approaches 0 of sine x over x is actually just 1, right? So we can prove this using something called the squeeze theorem. So on my open math there, I linked you guys to a video. It's a Khan Academy video that kind of shows you the proof of that. But for time's sake, I'm actually gonna jump through this one and just kind of get into some questions. All right. So in summary, you guys can use this, right? The first two are pretty much make sense. You don't even really need to memorize those because we can just figure out what, cos of 0 is. Ooh, and sorry guys, can you on your notes here? I think it's right on your formula sheet. That should say 1, okay, not 0. Just double check. Yes, it's right in your formula sheet. All right, so yeah, change it on your notes. Okay, trig. Okay, it's equal to 1. All right. So now let's actually figure this one out. So just like we were in earlier units when we were solving for limits, right? We would manipulate what we were looking at, so that well, before we were always trying to cancel something, right? We try to cancel something, and then that would like eliminate the dividing by 0 situation. Now, our general strategy for taking the limits of these is we're going to manipulate it, but then we're going to try to find a sine x over x somewhere in it so that we can call that 1. Okay, so I'll show you what I mean here. So let's write this again. So this is equal to the limit as x approaches 0 of cos x minus 1 over x. And now what I'm going to do is, just like I said earlier, units, one of the strategies we used was multiplying by the conjugate pair. So let's do that here. We'll write this out as cos x plus 1, top and bottom. All right. So then that would be the limit as x approaches 0 of, and if you expanded that all out, like FOILed the whole thing, we would get cos x squared minus 1 over x times cos x plus 1. All right, so what did that do for us? Well, one thing I'm noticing, I'm getting one of those situations where I've got a cos, well, that should be cos squared x, sorry. I'm getting one of those situations where I have a cos squared or a sine squared, and I've got a 1. That really seems like that could be one of those identities, right? Let's look at that for a second. So formula sheet. Well, this reminds me of this one, right? And if you rearrange for sine theta, it would look like this, 1 minus cos squared theta. So that's not cos squared theta minus 1, but it's close. Let's see if we can mess around with this and turn it into something we want. So I'm going to write this again as the limit as x approaches 0. And now what I'm going to do here to turn it into something I like is I'm going to factor out a negative. So we're going to factor out a negative, and then we have negative cos squared x plus 1. All right, well, that really is 1 minus cos squared x, isn't it? All right, and that's all over x times cos x plus 1. Well, I get to replace this now, right? This whole top part, that's an identity. That section right there. So let's rewrite this as the limit as x approaches 0 of negative, and then the rest of it is just sine squared x over x times cos x plus 1. All right, perfect. Now, why is that perfect, though? Or why is that useful? Well, remember what I was saying up here. What we want to really do is we want to find a sine x over x somewhere in this. So I'm going to split this up a bit. I'm going to try to pull the sine x over x out. So let's rewrite this now as the limit as x approaches 0 of, and then I'm going to write this as negative sine x over x times, and then the other, because this is sine squared x, right? So now the other one, so now sine x over cos x plus 1. Okay, so it was, yeah, hopefully you can kind of see that, right? I just split that sine squared x up and had the 1 over this x, right? That's that one. And then the other sine x was over this one. So that's that. Okay, so now remember when we take the limit, right, we're just going to throw the numbers in. Well, the good thing is I know what this is, right? We did the work on that before. Well, I didn't actually. I showed you a video where they explained why that was true. But so in this case now, we know that that's actually equal to 1. Okay? And now we'll just throw in our 0 in for the next part and see what we get. So I'm not going to write limit anymore because now we're going to say we're actually going to like throw the number in. So now this would be negative 1, right? That's equal to 1 times, and then this would be sine of 0 over cos of 0 plus 1. Okay, so this would be the same thing as negative 1 times, and then sine of 0 is just 0. Cos of 0 is 1 plus 1. Well, it doesn't really matter. We have 0 in the numerator here, so the whole thing would just become 0. All right, so that's what, so the limit here would be equal to 0. Now, like I said, this one actually is on your formula sheet, and it'd probably be a good idea to write it on here too, so we can remind ourselves, because we're going to be looking for sine x over x in the questions, and we're also going to be looking for this one as well, right? Cos x minus 1 over x. All right. All right, so this one, determine the limits of the following functions. Just check that we have a problem to begin with. If we throw 0 in for our x's, yep, we're dividing by 0 here. So we gotta do some manipulation to change it up. So here's what we're gonna do. We'll write this as the limit as x approaches 0 of, and then I'm gonna write the numerator the same, sine 3x over, and then I'm gonna rewrite this 6x a little different. I'm gonna write this as 2 times 3x. All right, so why is that helpful? Well, look at this part. Sine 3x over 3x. Like, I know that's not sine x over x, but it kind of is, right? It's like sine theta over theta, right? The angle is the same for both of those. So that's 1. Okay, so perfect. Let's throw it in. That would just be, well, here, I'll write it a little different. Let's pull it out so you can see it. That'd be 1/2 times sine 3x over 3x. And that's 1. So this would just be equal to 1/2. All right, so the next one, I'm going to write this out a little different to begin with. So let's write this as the limit as x approaches 0 of, and then the sine squared 5x, let's write this out like, you know, what's actually happening there. So what I mean by that is, we'll write it like this, sine of 5x and then squared. It's a bit easier to picture that that's sine 5x times sine 5x. Okay, and then that's over x squared. So now, yeah, we can write this a little different again, right? Because this is sine 5x times sine 5x. So let's write that as the limit as x approaches 0 of sine 5x, and I'm going to make it over one of these x's, and then times sine 5x over the other one. Now we're close. This is looking good, but it's not. That's not 1, because this is sine 5x over x. It would be 1 if this was 5 on the bottom and this was 5 on the bottom, right? Then that would really help me out. So let's make that happen. We can do that quite easily by just multiplying this by 5 over 5, and then the other one as well. Multiply that by 5 over 5. And now perfect, right? This is 1, and this is 1, right? You can kind of see it there. All right, so we'd say this is equal to, and then this is 5 times 1. Right, kind of skip this. You know, we're early into this. I should write it again. 5 times sine 5x over 5x, right? This is 1. And then times, and then the same thing over here. We'll write this as 5 times sine 5x over 5x. I just moved it around is all I did there, right? And that's equal to 1. All right, so this is just equal to 25. All right, so in this one, I think a strategy that we should use here would be to rewrite the numerator and the denominator as sine x over x. So here's what I mean. So we'll write this out as the limit as theta approaches 0. Now, the numerator here, what I'm going to do is I'm going to write this as, well, the way I want it. It'll be sine 2 theta. Now I'm going to introduce my own 2 theta on the bottom. Right? I'm just looking at this part right now. I'm not bringing up the denominator at all, or I'll deal with that next. But anyway, so I'm gonna just divide it by 2 theta, but I can't really just do that, can I? I have to multiply by that as well. Okay, so I didn't change anything, so this is my numerator so far. I'm just kind of like manipulating it so I know that that would be equal to 1. All right, so now we'll divide by, now looking at the denominator here, we'll do the same little thing. We'll write this as sine 7 theta, and then we'll divide that by 7 theta. But we also need to multiply that by 7 theta so we don't change it. All right, so now we'll write it again. So the limit as theta approaches 0 of, and it would be 2 theta times, here, you know what? Let's actually just write it like this. 2 theta over 7 theta. Okay? Times, and then it was sine 2 theta over 2 theta over sine 7 theta over 7 theta. And write it all again just to, I don't know, probably didn't need to. But anyway, so now you can see here, right? Why don't we do this? I've got theta over theta. I can cancel those. So that makes life easier. And then the next step what I'm going to do is I'm going to take this 2 over 7 and I'm going to bring it out front because we can do that with constant terms. So let's bring that out. So we got 2 over 7. Coefficient is what I should have said, not constant terms. So 2 over 7, and then times the limit as theta approaches 0 of sine 2 theta over 2 theta over sine 7 theta over 7 theta. All right. So then in the end here we get 2 over 7 times 1 over 1. So 2 over 7. Okay, D. Okay, so for D, there's actually 2 ways to do this. There's actually probably multiple ways for lots of these too, but here, let's do it. Here's one of the ways. So you could say, well, let's look at that. This is really a difference of squares. Let's rewrite that. So that'd be the limit as x approaches 0 of, and then that would be 1 minus cos x, and then 1 plus cos x over x, and then cos x. All right. So now I know that, you know, this looks like one of the limits we were talking about above. It was actually cos x minus 1 over x was equal to 0, the limit. Right? That was one of the situations. This is close. Why don't we factor out a negative out of that? We can do the same little trick we did before. So this would be the limit as x approaches 0 of negative, and then that would be negative 1 plus cos x, and then 1 plus cos x. Okay, and I'm going to write this first part over x, and the second part just over cos x. We'll just split it up right now. Well, perfect. Right there, right? That's equal to 0 because of this. So then let's actually, I'll just throw it in to save some time here. So this is negative, and then 0, and then times, and then this would be 1 plus 1 over 1. Doesn't really matter, does it? We're multiplying by 0. So that's all equal to 0. Okay, E. So the limit as x approaches 0 of 2 sine x plus 2, or sine 2x all over x cos x. All right, so let's write it out. So the limit as x approaches 0 of, I'm going to leave this the same for now. So 2 sine x. Now, this double angle here, right? That seems prime for me to change it into an identity, right? Like, if you can, right? Like, this isn't like a situation like above where we were able to rewrite it, you know, over some other angle, because that was just a single term here, right? The fact that we've got, you know, addition in between here, I'm not going to be able to do that little trick, right? So let's see if we can change things up a little bit by writing the identity for that one. So that would be plus, and instead of sine 2x, it's going to be 2 sine x cos x. And that's just on your formula sheet, right? over x cos x. Okay, now from there, I'm noticing that, well, in this term we have a 2 sine x, and this one I got 2 sine x. Let's factor that out. So that would be 2 sine x, and then we'd be left with 1 plus cos x. All over, I'm going to put this one right here, x cos x. Right over there a little more. Okay, so the reason why I wrote it over there, maybe you noticed that, look at this, sine x over x. Perfect, that's what we were looking for. Okay, so I'm just going to do one more little step here. Let's just pull that 2, that coefficient, out of this whole thing, right? It's 2 times all of this, right? So it's not going to make any difference anyway. Let's pull that out. So that'd be 2 times the limit as x approaches 0 of sine x over x times 1 plus cos x over cos x, and then we'll actually just perform this calculation. So this would be just 2 times, and that's 1, times, and then this would be 1 plus cos of 0 is 1 over 1, so 4. Okay, last one. So now we've got a tan theta involved. So tan theta, well, we can really split that up. Let's write this as the limit as theta approaches 0 of, and then this could be written as sine theta over, and then I'm going to leave the 8 theta down here, but then there's also a cos theta down there now as well, right? Because sine theta over cos theta. Right, now for this part, really we just need to kind of split it up. So this would be the same thing as the limit as theta approaches 0 of, I'm going to call this 1 over 8 times sine theta over theta, perfect, we know what that is, times 1 over cos theta. So it's the same thing, I just wrote it different. Okay, so now plugging all that in, that would just be 1 over 8 times 1 times 1 over 1, which is 1 over 8.